So whoever is having issues, and if you guys have YouTube access, please use this link. Okay, I'm sharing it on the chat. This is another YouTube session which will be streamed. I will create a playlist out of it, and you can follow these videos for your reference. Okay. So that being said, now let us start on the agenda for this 1 hour, for next 1 hour. The agenda for next 1 hour is to talk about HDFS. Okay, before getting into HDFS, Ravindra have asked a question about Ambari. So I am actually logging into Ambari now, and I am using my admin account rather than typical lab account. In lab account, you will have only the read-only view. Here I am trying to use admin, where I have full control on the cluster. So what Ambari can do is it can it provide two main things. One, wizards to set up the cluster. Two, reporting and alerting mechanism for supporting on daily basis, on day-to-day basis. So it is used for setting up the cluster and also for operations of the cluster. So when it comes to operations, if you want to configure alerts on any issues such as if any of these services is down or if any host is down, those things can be done using alerts. Okay, and the architecture of Ambari I will give at very high level. If you don't understand, we can take it offline, because it is not developer tool. It is primarily an administrator tool, and it is not within the scope of the overall course. Hence, I will just give a very higher level idea about the architecture of Ambari. It's a client-server architecture. There is a Ambari manager or Ambari server, and then Ambari agent. Whatever hosts that are visible under hosts, they will have Ambari agent running on them, and Ambari agent will keep on sending the information by monitoring what is happening on each of these hosts to the Ambari server. And Ambari server is configured with a database. It can be MySQL, it can be Postgres, and all this information which it collects from the agents will store in that database. And using that database, it will provide you reports about your cluster usage. It can send the alerts. Everything is taken care using the information it has retrieved from the agents and stored in the databases. That's how Ambari will facilitate the operations perspective. And when I say wizards, let's say I want to add a host to the existing cluster. As an admin, if I go to hosts and click on actions, there is add new hosts here. So I can give number of hosts with SSH private key. Once the OS is set up on that, and we need to execute certain prerequisites to make certain kernel level changes. Once that is done, you can punch in all the IP addresses of all the hosts and pass the private key. Give the account which have sudo access to root, and then you can say register and confirm, and it will go through these steps. First you have to confirm hosts, then you need to assign slaves and clients. You have to make certain configuration changes, review them, and then install, start and test, and it will take care of adding new host to the cluster. Even without any hosts also, you can directly, means if you don't have cluster at all, if the steps are first install Ambari server, and then when you go to the when you log in for the first time, it will show a wizard, and when you click on that wizard, it will take the IP addresses, and as part of the first time installation, Ambari server itself will install agents on all the hosts, and then it will install rest of the software. So Ambari will provide the infrastructure to set up the clusters, to manage the clusters or monitor the clusters, and also it provides certain developer tools also, like files view, high view, test view, yarn queue manager. We can configure whatever we want and give access to the developers and other users. So Ambari is a tool to primarily manage the cluster, and it's not a developer tool. It's primarily administrator's tool. But for the ad hoc querying and all those purposes, administrators can actually create something called views and give the access to those views to the developers or analysts to run ad hoc queries, etc. So that's brief overview about Ambari. If you have any questions, I can take it up. Otherwise, we'll move on to HDFS. Okay. Now we will.
Yeah, thanks a lot for that.
Yeah. So now we will get into HDFS. Again, here, if you go to any training, they will spend at least 2 hours on two things. One is block size, and second one is replication factor. And then they also get into too many details which are not necessary for the developers. Think from this perspective. And when you actually search online, you will be pulled into so many unnecessary details. Let's take the example of Oracle. You will understand what I'm talking about. So there is a question from Manjunath. He's asking, throughout this course, are you using only Ambari or even using Cloudera Manager? I will neither use Ambari nor Cloudera Manager. We will be using command line. Okay. Because Ambari is not a developer tool, or Cloudera Manager is not a developer tool. You can use Ambari or Cloudera Manager to retrieve certain information about your cluster, but you never use Ambari or Cloudera Manager for development purposes. Okay, for development you use tools like STS or Eclipse if it is Java or Scala based program, or you have to use Python notebooks, or you have to use some other developer tools to code, and then build the jar file or bundle your code in such a way that it can be executed by the operations team. Okay, so we will follow that standard process rather than using Cloudera Manager or Ambari, which are primarily intended for administration purposes. The cluster is set up using Hortonworks, hence we have access to only for Ambari. We don't have access to Cloudera Manager. So throughout this course, we will not see Cloudera Manager. Okay. So coming back to the point I'm trying to make, most of you are developers, okay, and you interact with database, and typical database is Oracle, and you don't even know how the data is stored in Oracle database. From abstraction layer, it is referred as table, and as long as you know how to create the table, that is more than enough to create the table. And as long as you know insert, update, delete commands to manipulate the data, that is more than enough. You don't need to understand what is a database file, what is a segment, what is extent, what is block. Those are all internals about how the data in a table is stored within Oracle. You don't need to worry about those things. Who need to be worried about it? Whoever is developing that Oracle database are the ones who need to worry about it. Even in Hadoop, all you need to know is how to store the files in Hadoop, or how to retrieve files from Hadoop. Some other commands which are required to manipulate those files, but you don't need to understand in detail about how the file is broken into pieces and how it is buffered while writing into the HDFS. All those things are not required. How the integrity of the files are managed, those things are not required. Okay, so here I will directly get into the commands that are required as a developer to read or write into the files into HDFS. Even if you go to any of the certification curriculum, okay, let's take CCA, Spark, and Hadoop developer. But unfortunately, the most of the evangelists in Hadoop world are the actual Hadoop developers themselves. And what they know Java, they know the internals of Hadoop, but they don't have industry relevant experience to build applications leveraging Hadoop or Spark. That's where you see a lot of unnecessary internals with most of these trainers. Okay, and if you go to the curriculum, this is the only this is the only thing which talks about load data into and out of HDFS using Hadoop file system. They're not talking about how data is stored in HDFS, how by dividing into blocks, what is replication factor. They don't care about all these things. But replication factor and block size are important. I will explain about those things. For certification purposes, even that is not required. Okay, so before getting into the HDFS commands, I will briefly explain how the HDFS architecture, how you can use Ambari to get the information about HDFS, and then we will get into HDFS. Okay, HDFS commands to store, load the files into HDFS or retrieve the files from HDFS. So if you go to Ambari and if you click on HDFS, if you understand these three things, you understand the higher level architecture of HDFS. You have name node, you have secondary name node, and you have bunch of data nodes. And here you can see there are 3 data nodes, and out of 3, everything is in started mode. Okay, and what does that mean? It means data nodes are nothing but slaves, and they are the ones which will actually store the data. And how the data will be stored, I will get to that point in a moment. And whenever file is stored in data nodes, it generates metadata. And what is that metadata, I will explain a little bit later when we actually copy the files. So name node and secondary name node are masters which manages the metadata of your files. Name node or secondary name node will not store any data. It will only store metadata of your files. Data nodes are the ones which will actually store the data. Okay, how it will store, we will see that. Okay, and now if you click on these links, these are all links. It will give the IP address of your name node, IP address of your secondary name node. In this case, S name node represents secondary name node. You don't need to worry about it for this course. If you are interested, I have content elsewhere. You can raise the issue in the relevant topics forum, relevant topic in forum, and I will respond with the link if you want to get into the internals of HDFS to understand more in detail what is name node, what is secondary name node, etc. But for this sessions, you just remember that name node and secondary name node is used to manage the metadata of your data. Your data will be stored in files. What is metadata is file name and other relevant information, and that metadata will be stored in or managed by the name node and secondary name node, which are masters in the cluster. And then data nodes, you see when you click on that, it actually takes you to the host space. There are 3 data nodes on the cluster, and each of the data node is configured with the 3.5 terabytes. If you just hover onto this in the tooltip, you can see the overall size and how much is actually occupied. We have 3.5 terabytes of storage, and as of now 410 GB of data is our files are stored on this host. In this host it is for approximately 410. In this is also almost same. Okay, because I will explain why it is almost equal a little bit later when we get into the details. But you need to understand that these are the ones which actually store the files. How it will store? To understand that, first let us copy few files into HDFS. Okay, and the way you can do is you can actually log in. So you can try now also. Let me finish and I will give 5 minutes time or 10 minutes time. You can try this from your systems, and if you run into any issues, you can write them immediately and I will clarify those issues. Okay, first you go to lab, bigdatalabs.com. log in with your account. Okay, this is the username and this is the password. So click on open console, copy this password by clicking on that. Username is D Adi Raju, password is, paste the password and log into the gateway node. And here we don't have any files. And one more thing which you need to understand is the difference between local file system and HDFS. HDFS is a distributed file system where the files will be stored in those worker nodes, but we are connected to gateway node. Okay, so when we try to copy files from or when we try to copy files into HDFS, first of all you need to have source to it, and that source can be your file system which is mounted onto this gateway node. Okay, or it can be in the local file system also. Typically it will be network mounted. I will explain the rationale behind that, but for now you should have access to files which you want to copy into HDFS locally. And before getting into that, here you need to understand what is the Linux file system and how it is organized. Okay, Linux file system actually starts with slash. Okay, slash is the root for the Linux based file system. And if you run ls-ltr, you can see subdirectories in that. And one of the subdirectories is data. Okay, so this is to just stage all the files for you guys to copy into HDFS and manage them. You will have read-only access to this directory. And here you have directory called cards. Okay, and if you go to cards, I will put other directories also in this, and I will, when I create the exercise which will be taken care of tomorrow, you will have access to additional files, and you will be copying different files tomorrow. Okay, and here when I say ls-ltr, there is a file called largedeck.txt. So it is local to this gateway node. Now I want to copy it into HDFS, and in HDFS we have 3 worker nodes, and this file has to be copied onto those 3 worker nodes. Okay, so what you can do is you can go type cd and go to your home directory. Your large deck is under this location, /data cards. This is the location of your large deck.txt, right? Now we want to copy into HDFS. Either you can directly copy from this location, or you can copy to your home directory and then copy into HDFS. It's up to you. Here I will be copying directly into HDFS. For that, there is a command called Hadoop FS. Okay, so more than internals, you should have knowledge about all the commands which fall under Hadoop FS category. Okay, Hadoop FS. If you just type Hadoop FS and hit enter, you will see bunch of commands you can pass to that as argument, and most of these commands are similar to Linux commands. So Hadoop FS is the main. Hadoop is the main command, and FS is the sub command of Hadoop to access files in HDFS, or to manipulate files in HDFS, or if you want to play with the HDFS file system or play with files in HDFS, Hadoop FS is the main command. Okay, and in that we have many sub commands. The most basic example is -ls, which is similar to ls in Linux. And when you say Hadoop FS -ls, it will list the files in the path you have specified. Now let me demonstrate that. Hadoop FS -ls, and for each and every account which is created in the lab, they will automatically a directory with /user/ the account name, which is this one. Okay, /user/ /d. This is the default user space for the for this user in HDFS. Unlike in Linux, where you have users, you don't find users in HDFS. You only find user spaces. You will not find users. Okay, and there is nothing like roles, permissions in at user level in HDFS. It's only on the host operating system. In this host operating system is Linux, and this OS user ID which I'm trying to use is D Gadiraju. For me, there is a directory under /user, which is a default user space in HDFS. /user/D Gadiraju. Okay, and hit enter. Right now there are no files in this location. That's why it didn't return anything. Now I want to copy files. Okay, so ls is the command which will list whatever is there in the directory, and you go through these commands. Most of them are self-explanatory, and they are pretty straightforward to follow. And you have to use these commands depending upon your requirement. So I will explain some of the very important commands, and then if you have any questions, you can ask either today or tomorrow, as long as we are talking about HDFS. Okay, so I will. You might be familiar with cat. If you are familiar with Linux, you will be familiar with cat. So cat is the command which will print out the data which is there in files which are stored in HDFS. And chown is the command which will change the ownership of your files. Chmod is to change the permissions on your files. Chgroup is to change the group of your files in HDFS. These are all to manipulate the properties of your HDFS files. And then if you want to copy data from local file system, you use copy from local. If you want to move files from local file system into HDFS by deleting the source files, you can use move from local. If you want to copy files from HDFS to local, then you have copy to local command. And move to local will delete in HDFS and copy the files into HDFS, into local file system. So to interact between local file system and HDFS, you have to use these commands which ends with local. And also there is another command called -put, which is similar to copy from local, and -get, which is similar to copy to local. So here is the put, and here is the get. So we need to be familiar with these commands to copy the files into HDFS, or to copy files from HDFS. Okay, so these are the important commands. Rm is to remove the file. Rmdir is to remove the directory, and tail is to just to get the preview of last 100 KB of data. And there are many other commands. You can explore these commands, and you can ask questions on any of these commands before we complete the course. But for the certification perspective, what is important? Load data into HDFS and out of HDFS. So from certification perspective, the most important commands are copy from local, to copy from local to HDFS, copy to local, to move to copy files from HDFS to local, or put and get alternatives for this. If you want to get help on any of these commands, you can say Hadoop fs -help and give the command name, copy from local, and it is saying it is identical to the put, and check for put. So here I am saying, instead of copy from local, put. So these are the three different control arguments which they have given. -p will preserve access and modification times, ownership, and the mode when you copy files with -p using put or copy from local. -f overwrites the destination if it already exists. So if the directory already exists in HDFS, and if you are trying to give the target directory with the same name, then it will fail. If you want to overwrite, you can use -f. And you don't need to worry about -l. It is primarily uh, uh, something called lazily persist. I am also not 100% sure, and you don't need to be worried about it. Okay, and they are also saying you have to use with care. And that being said, now we will try to copy the file largedeck.txt into HDFS. How to do that? Hadoop fs hyphen copy from local output. You can use either of them. And if you hit enter, it will show you the usage. And if you look at it, if you want to use these control arguments, you can use. If you these are all optional, and then you have to give the local path. So wherever our largedeck.txt is there in local path, we have to give that local path, and DST is for target in HDFS. So the command will look like this: Hadoop fs copy from local is under data parts, and we can pass the directory name also. And the directory name, you have to use your directory only. You will not be able to write to any other directories. This is my directory, and here I can hit enter and it will automatically create the directory, or I can say slash and give the some other alternative name also, if you want to give different name than whatever your source name of your source directory. So here I am just giving like this, and that cards directory will be created, and then it will have the largedeck.txt file. If you want to create the directory and if you want to copy files, you can use Hadoop fs hyphen mkdir. Okay, it will do copy recursively. You don't need to pass any additional argument to copy the files recursively. That's what we are getting into the details. I will explain how it will be actually stored in HDFS. Okay, now this cards is in local file system, and the cards which is under HDFS is not in the local file system. It's in those three worker nodes. And how it will store it in those three worker nodes? One of the easiest way is to use name node web interface. I think Tavantians do not have the name node web interface access, but others have the access. So what you can do is so we can go to this link, and here you can see click on name node, and it will take you to the name node web interface. Also you can use Ambari. In Ambari also you can actually, sorry, in Ambari also you will have the bookmark to this under quick links. So if you want to use Ambari, you can click on this login, and in the Ambari, if you go to HDFS, under quick links you will have name node UI. You can click on that also. Both will take you to the same location. I have bookmarked on the quick links section of this page. Okay, so now we want to see. Okay, I will create after this session. Okay, I think you didn't sign up yesterday, so that's why I missed out. There could be some issue also. We will take care of it later. Click on browse the file system, and here you can go to user, or actually you can give the path directly here. So user B Gadiraju, that is my home directory. Okay, why it is complaining? Okay, it is trying to. Let me see. So quick links, name node UI, utilities, browse the file system. Okay. I think using name node UI, non-administrators might not be able to access because only owners have access on this on these directories. That's why using name node UI it is not showing. But I will show you using a different location which is accessible to everyone. So in the HDFS itself, there is a public directory, and that public directory have the same data cards, and you can see the large deck.txt. So to get the metadata of a file, if you have access to name node and if there are no permissions issues like this, you can actually click on large deck.txt and it will show you how the file is stored. And the file actually divided into 6 blocks. Why 6 blocks? There is a parameter called dfs.block size. Okay, so as you are all experienced professionals, for any software there will be parameter files or configuration files which will control the behavior of your software or application, right? So in HDFS also there is a there are set of configuration files. Again, you don't need to worry about at this time. I will cover about configuration files a little bit later. Here, to get details about the block size and replication factor, which are two most important characteristics of HDFS, you can go to configs and you can search for block size, and you can see it is 128 MB. This is 128 MB. It is in bytes. Okay, this will resolve into 128 MB. And if you go to this file, you can see each of these blocks except the last one is 128 MB. Okay, so what happened? The file is divided into blocks, and that block is assigned a unique block ID, and this block ID is unique across the entire HDFS. One block ID will not be associated with more than one file. Okay, it's unique across all the files. In this case, it's a 700 MB file or 720 MB file, and because our block size is 128 MB, it is divided into 6 blocks, and the last block is only the leftover 55 MB. Rest all of them are 128 MB files. So this is how the file will be divided into multiple blocks, and those blocks will be stored in our worker nodes. You can see the information over here. Availability of each of these blocks are on these 3 worker nodes. Okay, so what happened when we run Hadoop fs-put command or copy from local command? Internally, it actually divides the file into multiple blocks, and those blocks are actually stored on the nodes. And on top of block size, there is another important parameter called replication factor. Okay, and the default replication factor is 3. Here our cluster is configured to 3. I will change it to 2 very soon, so that more data can be stored for practice purposes. But this is the parameter which will control number of copies of each block. So what happening here? Each block is created with 3 copies, and each copy have gone to 3 different nodes with the same block ID. Okay, so this is how the file will be stored in HDFS. So the location of these files are on these 3 nodes. Each of the block. I will show you how it will be stored. On top of this replication factor and block size, there is third parameter which is called as data directory. Hello, can you guys hear me? Yeah, I think you guys can hear you. You guys can hear me. Okay, so there is something called Actually, if I click on settings, here itself you will see. You can see data node directories are these two locations. Okay, so on each of those worker nodes, you will find directories defined here. We have to first mount the mount points, and we have to define the directory names, and it will create as part of formatting the name HDFS, Hadoop distributed file system. Okay, now I am logging into the cluster. You will not have access to this because I am logged in as root, and you will not have access to data nodes also. But I will log into the data node and show you how these files are actually stored. So first thing is, I have used the web console and store the files into HDFS using dgadiraju, which is my account. So here I am sudoing to become dgadiraju here, and then I have ran that command, whatever command earlier. Let us confirm that it is visible from here, user dgadiraju, and then cards. You see the file, and even though you don't have access to that metadata using name node, there is a command called HDFS FSCK. You can use this command to get the metadata of your files. So if you give HDFS FSCK and hit enter, it will give the syntax, or it will give the usage. So the usage of HDFS FSCK is, you can give HDFS FSCK and the path of the file, and then there are three control arguments called files, blocks, and locations. Okay, so HDFS FSCK, the path is user dgadiraju parts, and if I just give files, it will give list all the files that are stored in that location. There is only one file, and this is the information about that file. It is 720 MB. And it is divided into 6 blocks. It didn't give any details about the blocks and locations. If I want to get the block IDs and locations, I can use -blocks and -locations and hit enter. You will get all the information about each of the block, on what all nodes it is stored. Here it will not give the aliases, it will actually give you the physical IP addresses of each of the nodes, of each of the worker nodes. Okay, and now if I want, I can log in. I have to exit from here. Now I am trying to connect to worker node. I logged into worker node, and if you copy paste this location, because this is the location where we want to copy the files physically in distributed file system. Okay, I can say cd and ls-ltr. Here you can see current directory. Okay, and if you run this find command, okay, it will give the information about all the blocks. Okay, don't worry about what is this meta and all. The main files are these ones. Okay, and you can see the block ID here, and this is the physical name of your file. In HDFS, the logical name is whatever name it is used to copy into the system, which is logitech.txt. But physical files which are stored on worker nodes you will use the standard names with BLK as prefix and the block ID embedded in it. Okay, this is how it will store. And there is a question, let me answer that. Block ID will be same in all the 3 nodes. Yes, block ID will be same on all the 3 nodes. That you can actually go to you can log in with whatever username you try to use, and then you can use HDFS FSCK command to see to get the information. HDFS FSCK user dgadiraju cards large deck.txt files blocks locations. Okay, and block ID is this one. Okay, and this the file with this name will be there on all these 3 nodes if the replication factor is 3. If there are only 2 copies with replication factor 2, then you will see only 2 copies of it. If it is 4, you will see 4 copies. Okay, so this is how the file will be stored in HDFS. Okay, HDFS FSCK is a very good command to actually understand how the files will be stored. And now let us come. So I hope you are all clear that data will be stored or files will be stored in a distributed file system on worker nodes in the form of blocks. Okay, now let us understand the relevance of name node little bit. Whatever information we are seeing using HDFS FSCK or using the name node web interface by going to that file is called as metadata, and this metadata has to be managed by someone, and and that's where the name node and secondary name node comes into picture. So they preserve this metadata mapping to the actual file. So in this case, file name is this one in HDFS, and for this logical file name, this is the metadata which will help us to determine where our files are, what are the permissions that are available on those files, etc. And all this termed as metadata, and that metadata will be stored on the servers which are designated as name node in memory. It will always be stored in memory. Okay, because memory is transient, if name node goes down, metadata will go away. To address that issue, there are a couple of file systems, file structures, FS image and edit logs. Those will be used to maintain the metadata in the files, and if name node goes down, when it comes back up, this metadata will be restored and recovered on the name node, and you will be able to access the files. And until this metadata is restored and recovered onto the name node, you will not be able to access. Anyway, you don't need to worry too much about it. You just need to understand how the files will be stored and what name node will contain as a developer. You don't need to worry about that FS image, edit logs, how the restore recovery will take care. You don't need to worry about it. It is the job of administrators. If you think about Oracle also, you don't worry about taking the backups of your data, or how the redo logs work, how the recovery process takes place. As an application developer, you don't need to do you don't need to be aware of those things. So try to avoid to get into those details about how the name node will be recovered and all those things, especially from the certification perspective. Only thing that is relevant is Hadoop commands or Hadoop FS commands to copy files into HDFS and to copy files from HDFS. If you want to understand basic details about how the about the metadata, you can use this HDFS FSCK command. Okay. So any questions here? So I will give this rest of the time. You can practice the command. I will not give any hints here. Only hint I will give is Hadoop FS. Use this command, and the problem statement is copy files from this location, data cards, into your user space. Okay, I will create an exercise by tomorrow, and you can provide the output tomorrow on a different aspect. In the exercise, I will give something different, not this one. We have something called retail DB, and we have New York Stock Exchange data. So we will use that data to actually copy tomorrow. I will give an exercise even tomorrow and make sure that you all copy that. For now, just try to understand the relevance of Hadoop FS, and in that process, try to copy that largedeck.txt file with the cards directory in your user space, so that you get familiar with Hadoop FS. Tomorrow, I will give the next. comments, let me know. Not necessarily only to copy the files. If you have any question of any of these comments, I will be glad to explain. Hello, can you guys hear me? Can someone confirm on chat? Okay, that's cool. And also, please join with your names tomorrow. Otherwise, there are so many people who didn't give their name. If I have to refer you, I don't know the names while responding. So please join with your names. No need to include last name, just use your first name. Okay, and people on YouTube, I am actually streaming to YouTube so that the people who are attending in this WebEx sessions have the videos for their reference. So I will be disabling the comments from tomorrow. So I will not be able to answer your questions as part of these sessions. These sessions are primarily for the audience in the WebEx who are paying me for these live sessions. But in even if you don't pay, if you are just following on YouTube, if you have any questions, you are feel free to raise those questions as part of the using discuss.itversity.com. Okay, Manjunath MK. Let me give him the lab access.
Okay, Vishwanath, I'll drop off, Vishwanath.
Yeah, sure. Thank you very much, Ravindra.
Yeah.
Yeah, Shashank, I will do that. I will take care for Manjunath and Shashank meanwhile, you guys can actually practice this Hadoop FS command. And we are almost done with HDFS. Don't expect too much material on HDFS. We'll do an exercise satisfying the certification requirements, but we will not get into too many details about HDFS. If you are interested, again, you can raise it on the relevant topic, which I will be creating as part of that itversity.com blog, and I will give you the reference. I already have the material in YouTube. Okay, let me try for Manjunath. Meanwhile, I will stop the Google Hangout session. Thank you very much for everyone who joined the Google Hangout. If you have any questions on this topic, you can write it on discuss.itversity.com. And we will be having these sessions for next couple of months. If you want to follow, you can subscribe on the channel, and you will get the update whenever I launch these sessions. Thank you. Bye. I am stopping the